My name is Blake Hauser. This is my Math 253 Project 1. We were given natural log of 1 plus x, and we were supposed to essentially turn it into a Taylor polynomial. What I first started out with doing was I ended up taking the derivative of each. And when I started taking multiple derivatives, I started to notice a trending pattern, and it would alternate between positive and negative. And it was able to give me a formula which ended up being -1 to the n minus 1. I have my negative, or n minus 1 factorial over 1 minus x to the n, and that gives me my f to the n. Then you just turn into Taylor polynomial. The first term doesn't count because it's just 0. And then you just see how I cleaned it up here. And it gives me x minus 1 over 1/2 x squared, and this is where you start to notice pattern, plus 1 over 3 times x to the third minus 1 over 4 x to the fourth, and it will repeat that same pattern. This gives me a formula for my Taylor series. Can't be 0 because if I put in 0, it's undefined. So that's why I start with 1. And because I've already set this up, now I can actually start answering some of the questions. So it asked me to determine the n value for the error at when x equals 0.5, and it gives me an accuracy variable. And so what I did is, because I had my f of n, it wasn't hard to turn into n plus 1. This gives me -1 to the n, and then I have my n factorial, and then that is 1 plus x plus to n to the plus 1. And then I can just set my x value to 0.5, which is what I got here. And to really just help me out, what I ended up doing was just graphing the series. So I'll show you what I did here. I hope this shows up well. So you can see I plugged in my Taylor series, and really when we look at 0.5, I noticed that it didn't ever go above the value. It's like at 0.41, but I just put 0.45 because it's really not going to matter, because you're going to see in just a sec. So I'm going to go back here. So I did some rearranging here, and it gives me a value of 45. So 4,500. I really just have to get around this value. You can see my factorials, and so when I reach 6, that's when I get to 50, 40. So my n equals 6, turning into the Taylor polynomial. I go up to my 6th value. Now I have to do my Lagrange remainder. It's my Taylor series plus my remainder. I just went up to 7th factorial. You can see my work here when I actually plug it in. And when I set my parameter 0.2 for my x, you'll notice that versus the value that I get. And then this is actually what it comes out to be. That's my project.